Hi all, welcome to another episode of Fascia Demystification.
This is the third episode of our program and second part of Fascia Explained. Anyone missed the first two episodes, I kindly request to watch the first two by clicking the channel and seeing the session 1 and 2 in order to maintain the continuity of the information. The mysterious fascia. Fascia seems to be integrally involved in the biomechanics of the musculoskeletal system. Body moves in multiple planes, not as isolated joint motions, but as fluid motion involving multiple segments, which needs of different fascial layers over one another. Just imagine the fascia sliding over one another when you are stretching the body to one side, and at the end range, the additional gain of length thanks to the sliding system of fascia, which is influenced by the natural lubricant called hyaluronic acid or hyaluron and water it holds. The picture taken from Stecco in this screen demonstrates the presence of hyaluron between different layers of fascia, and the details of the same will be discussed in later sessions. Fascia involves in myofascial force transmission since it is a continuous structure. The human body must be considered as a functional unit where every area is in communication with another through the fascial continuum, consequently originating perfect tensegrity equilibrium, an equilibrium which is made up of the concept of tensegrity. The fascial continuum is essential for transmitting the muscle force and is referred to as myofascial force transmission. As the name indicates, myofascial force transmission considers transmission between muscles and non-tendinous connective tissue or fascia that is forcible or feasible in either directions. The classic view of skeletal muscle is that force is generated within the muscle fibers and then directly transmitted in series. This is what we have learned in anatomy. And it is usually via tendon onto the skeleton or the bone. So muscle force is originated inside the muscle and which will be contracting through the tendon and pulling the bone. This is the classical anatomy we have so far learned. In contrast, recent results suggest that muscles are mechanically connected to surrounding structures and cannot be considered as independent actuators. We use the term epimuscular myofascial force transmission, epimuscular. Or you can say it's a force transmission across the muscle fibers into adjacent muscle fibers or adjacent structures, or even to the opposite muscle groups, or it's called antagonists. Or let's say it's transmission of muscle force to the skeleton via pathways other than the muscle origin or muscular origin and insertion. The picture shows the different pathways of force transmission from muscle to bone through myotendinous junction. The first one, that is the intramuscular, is a classical one. And the epimuscular pathways are the second and third. They are intermuscular. If force is transmitted between two neighboring muscles where the continuous connective tissue at their muscle belly interface. And the third one, you can see extramuscular, if force is transmitted between the epimysium of a muscle and an adjacent non-muscular structure. So you can see how different types of myofascial force transmissions are happening. And many of the studies are saying that 30% of the muscular force are transmitted through the second and third, or you can say that through epimuscular myofascial force transmission, 30%. Just think about an example of somebody who is having a tight hamstring and complaining of back pain or neck pain. And just think about that continuity of the fascia, which is actually connecting from the sole to the head and transmitting the force accordingly. Again, this will be discussed in detail in one of our upcoming sessions, because the mysterious fascia continues its properties. Fascia facilitates the body shape and force, and it is the on defining or extending your anatomical boundaries. It's everywhere. So there is something called passive fascial force, which even creates the tension for you, and the tensegrity the fascia provides keeps you standing, walking, and all. So this is a concept which we will be discussing on tensegrity session. Fascia may contract like smooth muscles, even though it will be slow, sustained, and lower amplitude. A lot of studies are happening. The role of, like fibroblast at times will be converted into myofibroblast. That means fibroblast with some contractile properties. So a lot of studies are happening, especially with Robert Clive and teams, which says that there are certain fibroblasts are already converted or acting like myofibroblast to produce a slow, sustained contraction necessary for maintaining the fascial tone. And fascia can become inflamed and potentially cause pain because of its widespread innervations and tension producing capacity. As I mentioned elsewhere, fascia contains lots of free nerve endings, and if it is inflamed, like it causes peripheral sensitization, later it will lead to central sensitization, and like fibers will be converted into nociceptors, and the cascades of pain event starts. The fascia plays different physiological and functional roles related to joint stability, general movement coordination, proprioception, nociception, and is associated with wound healing. One of the major things you will be learning about fibroblasts is wound healing and tissue repair. Many connective tissue pathologies also actually there with fascia. Fascia is a continuous structure that attaches, stabilizes, encloses, and separates almost all internal organs, including muscles and bones. The fascia embodies the element of structural interconnectedness around, within, and between body elements, starting from the cellular level. It's simultaneous sliding and gliding. So fascia slides and glides. Motions is the main reason for this type of properties. Since it appears everywhere in the body with its characteristic structure and functions, it has been referred to as both of an organ of form and as an organ of inertness because of its phenomenological dimension of in between the outer and the inner boundaries of the body. Mechanical tension signals from the extracellular matrix are transferred through between membrane mechanoreceptors or transmembrane mechanoreceptors to the cytoskeleton and to the cell nucleus, from the outer side to the inner side of the cell, while being transduced into a chemical information. And this process is called mechanotransduction, coming from outside to inside and changing into a chemical signal or information. So impacting on various aspects of cell behavior and metabolism via the modulation of gene expression. And maybe you'll be thinking about the mechanotransduction. Living cells are constantly exposed to mechanical stimuli arising from the surrounding extracellular matrix or from neighboring cells. The intercellular molecule processes through which such physical cues are transformed into biological response are collectively called as mechanotransduction. So this is the process where the cells transmit informations. Now we'll be directly coming into more systematic way of explaining fascia, and we can say it is a fascial anatomy diversification. Fascia, in a broader way, can be explained under two main divisions: microfascial aspects and the macrofacial aspects. So microanatomy and macroanatomy, that's the difference. Under microfascia are the cells. We will explain about fibroblasts, fasciocytes, cilicocytes, and so on here. Then the extracellular matrix, the one which, the environment around the cells. And we'll explain about active fibroblast and its role in fascial remodeling and plasticity. Then we may go for fascia receptors. They are specialized receptors in the fascia for various hormones and biomechanical products. The last in this area will be the receptors, and we will explain it under three: exteroreceptors, proprioceptors, and interoceptors. Regarding the macrofascial component, we will be explaining about the fascial connectivity and continuity, myofascial force transmission and tensibility, fascia innervation, fascial remodeling, and myofascial sliding and its relationship with different structures. Well, that's the end of our session 3, and please reach us via fasciadr@gmail.com for any queries, or if you want to hear anything or any related topics. We can even have discussions on it in our platform.
There is a query on exactly how to pronounce the fascia. So it is
fascia, fascia, fascia.
Our next section will explain about types of fascia, and we will see you there again. Please subscribe, like, and share this knowledge platform to spread the knowledge of fascia, and be in our contact so that you won't miss any of our episodes. Till then, bye-bye.